Okay, good morning, good afternoon, and welcome to this week's Lunch and Learn by yours truly, Dan Hotka. Okay, just my short disclaimer. Um, for those of you not familiar with my background, I am an Oracle ACE director. I've also been around the Oracle product for a significant length of time. I'm well published. I need to update this slide. I've got 14 books, hundreds of articles. I regularly blog, mostly on the Toad World site. I do these lunch and learn webinars, and you're welcome to register on my website. You go to my website, which is conveniently plastered on all of the slides, and you can register for these, which will get you the link the Friday before. The link is always on my website the morning of the webinar, so you can go right to my website and click on the link to join as well. Last year, I was busy turning my courses into Safari books online. Check with your HR department. You might already have a Safari account, particularly if you're a bigger company. They've got DVDs for purchase, my tuning class, the PL SQL classes I teach, the OBI class, Toad class. There's 6 altogether, and they bundled the intro and advanced PL SQL classes together to come up with a complete class, little bit better price. I still do training on site. I can also do training over the web. So if you want a little bit more customized class or the ability to ask questions, it always goes better when you have an instructor-led class versus the training videos. And I'm still available for that. I still have my portable lab. So we're doing these lunch and learns. I'm still available for training. I'll do consulting if necessary. And Bert and I updated our Toad book. So this is available on Amazon. There's also discounts on my website to order this. And I have taken my tuning knowledge that I've been sharing with everybody for years and stuck it into my SQL Tuner tool. I've renamed JS Tuner to SQL Tuner. That's the free explain plan tool I've been giving away. I have found, working with as an ACE director, I get access to some of the Oracle people, and they were using some fancy syntax that I had not seen before. Asked them to show it to me. I embedded it in this. The other thing that this tool does that's really powerful is it will show you the current SQL executing. You highlight the SQL ID, press the Go button, and you will get the fancy explain plan. You'll get bind variable content. If it's Oracle 12, it will show you the adaptive plan. I am very pleased with how it all came out. And I sell it at a very affordable rate, and it needs no additional Oracle licensing. So it works great on standard edition Oracle, which you're not supposed to be using Enterprise Manager against that. So again, you want to see what is currently slowing your system down, what is currently executing. You can use this. I've got some options in there to allow you to search the library cache for specific SQL. I talk about that in my tuning class. And since it was easy enough to do, I allow an option to show all the SQL that's in the library cache, all of the dictionary SQL as well, all of the stuff that Oracle's firing. So useful tool. Let me know your level of interest. Again, on my website, there's a fact sheet for it, but I would like to chat with you some more about it. Today, we're doing the Oracle Optimizer internals, a close look at the 1053 trace. Next week, we're going to be doing the OBIEE using the KPIs with a live demo. And then this short series will end on February 9th. Everything's off a week. You know, I almost had technical issues today. The computer that I run these on decided it didn't want to boot being a Monday morning. I don't know what's wrong with it. It's going into the shop this afternoon. And I'm going to go ahead and have it upgraded to Windows 10. So I'll have a current PC as well. So anyway, there's the schedule. Today we're talking about the 1053 trace, the cost-based optimizer trace. Now this trace is something, it's been around a long time. I talk about it in the tuning class. I should probably show it more in the tuning class because I go through how exactly the optimizer works and which I'm probably going to review this. We'll probably redo this with a little bit more information next time. But I like to keep these lunch and learns short, so I don't want tons of information in here. I don't want them to go an hour. But at any rate, I have a nice flow chart on how the cost-based optimizer assembles an explain plan. The nice part about this trace is it confirms all of those things that I talked about. Shows the SQL statement being processed. Shows the init.aura parameters that are set. It shows you predicate processing, i.e. the where clause. It shows you the join conditions. Shows you the explain plan. Gives you an outline, optimizer environments, and some key statistics associated with the SQL. Now, the real key to this is if you want to know why did Oracle pick the explain plan that I picked, this is a useful trace. The other thing that it might be useful for is if you work in one of those shops where your boss, your supervisor, likes tons of technical detail, you can copy and paste out of this thing and make your report to them look really technically competent with tons of technical jargon from inside this trace. So the other thing that is probably useful for in the real world is if you've got hints. This trace will tell you if it found the hint, if there were syntax errors in the hint, and if it used the hint. Now, this is something I'm going to probably put an interface up for, so watch my announcements as I talk about it, but it's going to be the 1053 trace browser or some name like that, because I'm also going to put one up for TK Prof. I'm working on how to run TK Prof on the server, so if someone's got some server-side code that executes commands on the server, please share that with me, and that will aid in my programming. So, at any rate, the 1053 trace useful trace. I have written a couple of scripts here that show you that will run the script, turns on the session. There it is, alter session, set events, 1053 trace name context forever. Don't know what most of that means, but you do have to have privileges to alter the session. Run your SQL statement, and then alter the session, set the trace name context off. That turns the trace off. It creates a trace file in the user dump dest, or a better location is the background dump dest. Okay, background dump dest. And I've already updated the scripts for this. So this run trace 1053 trace is kind of nice. What this does is you put your SQL statement into a file called SQL file, okay, and then you just, in SQL Plus, you just do a start, run trace 1053, okay? It turns on and off the trace and gives you the trace file name. This is what it looks like. So you start the run trace, it prompts you to put your file in SQL file.sql, hit return to continue when you're ready, and then it tells you where is your trace file, what your trace file name is, and it executes the file, creates the trace file. Now, this is very useful information because if you don't have access to this location on your server, this is what you need to email the DBA staff and say, please, may I have my trace file? So this is what the trace file looks like, and we're going to look at a real one here. There we go. We're going to look at this trace file, and this is my famous ABC file, but we can look here and it tells us immediately all about our Oracle session. There's our total memory, what we're running it on. Okay, so there's that technical jargon that I was telling you about. You can embed in your reports. Okay, here's some more. There's your session ID, client info, all this good stuff, how you're logged in. Okay, now there's 3 tables in here. This is where Oracle is assigning a signature block. It's going to assign the first one to the spot 0, the second one to 1, the third one to 2. Okay. The other thing that it's doing is there's no subqueries. So all of the rows. I call it result set, but it's row sets. As they're passed up, they're going to be stored in the select $1 signature block. Okay, that's That's the temporary area where it stores the rows while it's passing them up, the explain plan tree. So let's look down here a little bit further. It tells you about the degree of parallelism. It's disabled. This is not a parallel system. Predicate move around. Okay, this is cool. There's the SQL statement that I submitted. Okay, and it's got a couple of hints in it here, but that's the SQL statement that I submitted. Okay, predicate move around. It doesn't actually shuffle these, but it considers the where clause predicates in different orders as if you shuffled them. So let's look at some of these things that I've talked about in my tuning class. Query-based query transformation, cost-based query transformation. Okay, this is opening up access paths. Since A status equals B status and C status equals open, we're going to see where it's going to put an A, and there's B status equals open. We're going to see where it puts an A status equals open into our code, and that's the SQL statement that actually gets submitted. This trace will also show you the SQL statement that actually got submitted on your behalf. It isn't the one that you necessarily submitted. It's got these predicate move arounds. Let's look at some more of these. There's PM is predicate move around. You got all these different things that I've talked about. Okay, here is some statistics. Okay, leaf blocks, data blocks per key, clustering factor. I got a whole thing on, just a plug for my tuning class. Whether you take the video, you have me on site. I think the cost of the entire class is worth the part that I talk about just on indexing, how clustering factor relates to the underlying table, all these cool things. So like I say, I think the indexing part's worth the cost of the class alone. Nested loops. This I talk a little bit about. In fact, I'm putting a presentation up on this for user groups. It's going to go the full hour, not the 20 minutes. But I'm going to show you the different things that are involved in a hard parse. And one of the things that Oracle does is it does not know which one's better for a particular join condition. Nested loop, sort merge, or hash joins. Okay, it tries all three, and we're going to see this in this trace file. It tracks some other statistics. Okay, so. And then there's some distribution methods, and here's the first set of init.or parameters. These are the ones that were used by the optimizer. So these were the ones that were set either by an alter session or a hint or something, but these are the ones that were used by the optimizer. And notice it's a list of them all. We got these ones with underbars. These are the undocumented hints. All kinds of init.or settings, okay, and how they're set. We're going to see this a couple of times. The tool that I'm going to put together is going to take these bug fixes out. I'm going to clean this up a little bit. So it'll take all of this stuff out. There's quite a bit of this. But if this is in there, I'm going to not display it. So like I say, I am going to put a display up for this so that you can run this. You put your SQL in the window, push the run button, and it's going to run the 1053 trace, pull back the trace file, and put it into the tab files and show you this useful information. Here's your query-based transformation. Checking for join factorization, okay? It's not a union or a union all, so it's not going to do any of those query transformations. These are all the different query transformations that it's going to do. It's not finding much to do here, okay? It's not going to bypass anything. So here is unparsed query, considering view merge. It's not going to find one. Considering join elimination on query block. And it didn't change anything yet. You can see here unchanged, unchanged. Considering different join operations, join elimination. And here is generate transitive predicate. Okay, that is the additional where clause item. So there's the filter pushed. C status equals open. There's the B status and C status equals open. This is the one it added. Okay, remember that was not in our original query. It did add this. Why? Might be an index on that. It might be a better thing. The Oracle people call this opening access paths. Okay. Are there any peaked bind variables? No. By the way, my active SQL program will show you peaked bind variables, and it'll show you all the bind variable content. Okay, so there's the SQL statement. By the way, this is the SQL statement that got submitted on our behalf. So now we're back to, there's the one we submitted. There's where it's assigning everything. It's got its object IDs. Okay, this is why when you use aliases, it resolves the alias back to the object ID. That's why you need to use the aliases and the hints. There's some more technical information for you. There's the different speeds on the computer that I ran this. Okay. And then there's some basic stats. Pulls the stats in. There's the stats for the C table, the B table, the two indexes that were available, their clustering factors, everything. Single table access paths is going to keep track of this. And it's going to do that. And then begin join costing. It's going to look at some index accesses. And then here is the first permutation, okay? And again, I'm going to have my little flowchart slide in here. When you see this next time, I'm going to talk a little bit more about how the cost-based optimizer puts things together, and then refer you to this trace that I'm making today, this webinar that I'm making today, because I like to keep these short. So there's the permutation. Here's the first permutation. Join order. And remember, if anyone that's been in my class, I talk about shuffling the tables in the join order. This is exactly what it's doing now. So it's going to start with B, it's going to bring in A, and then it's going to bring in C at the end. So that's the join order. 0, table 1 is B, table 2 is A, and table 3 is C. So now it's going to do a join order, outer table and inner table. It uses that same syntax that I'm talking about. The outer table is the B, the inner table will be A. There's the nested loop cost. There's the join, let's see. What did it do here? Every time I look at this, I discover something a little bit more. So there's the outer table and the inner table. This is looks like the sort merge, although yeah, it is SM. I was just going to say it usually says SM. There's the sorting requirements for the sort merge. It came up with a low cost, and then here is the hash join. Okay, it came up. Best method so far is hash. Okay, so I remember when I say it does these permutations, it remembers the best overall cost. So there's the cost of joining B and A. It's going to use a hash join. And then now it's going to bring in C. It's going to try the nested loop. It's going to try the sort merge. And it's going to try the hash join. Okay? And it did some interesting work down here. Best method so far is the hash with a cost of 11. So there's the best so far. Next permutation. Going to do B, C, then A. Does the same thing. Nested loop, sort merge, hash join. Okay. Best method so far is hash. We're going to see down here where it's kind of interesting. We're just going to start scrolling here. Join order aborted because the cost is greater than the first one. Okay. This one happened to match up. But it took the other one. Remember, I said that in the tuning class that it's that cost, the overall cost of the query, that cost on the top line. That's the one that the cost-based optimizer is looking to beat. It's looking for mostly that cost number is mostly physical I/O. It takes these machine speeds and these other things that we've seen displayed in this trace file into account. Okay, but it does take this into account. Now, next permutation, it's going to take A and B. Drive off of A, bring in B and C. And if you look here closely, you'll see it using indexes, not using indexes. It's just trying all the options. I call this brute force. Okay, it's just trying all the options. It doesn't know which one's the lowest. It uses the fancy math on where clause predicates to kind of come up with cardinality per line of the explained plan, but it really doesn't know which join method is going to be the best. So it literally thinks about trying them all. Okay, so here it is. The best method so far is hash. Now it's going to bring in the C table. I believe it aborts this one too, because the first one it came up with had that 11. Now it's going to take A, C, and B, and it's not going to like this at all because this is a Cartesian join. Notice it aborts right out of the gate, comes up with a great big huge cost number. So join, it aborts this one too. Now it's going to take C and B and then bring in A. Okay. It converted the indexes to bitmap indexes. How about that? Tells you everything that it did. If you, like I say, if you want to know why it came up with the explained plan it did, this is your trace. So there it's going to bring in the A table. And then down here it aborted because the first one was still better than this one. In other words, they're matching up. So it kept the first one. So now we're done with the joins, and it aborted on the last one too. So it did 6 permutations. Okay, gives you some useful information on things that it did. And the stop keys and the status, and there's the A status equals B, and the C status equals open, and where's the A status? There's the A status equals open. And where it got used and all that stuff. So I find this is, I don't know, just technical information that may or may not be of use to you. So we go down here. There's our SQL statement again. There's the length of it. There's the explained plan it ended up with. You take that cost, that overall cost number, and that's how you match it back up above with which one goes with this. Notice it picked the hash joins, started with B. That very first one it did is the one it picked. B, A, then C. It still did the other permutations though. Notice that just because it started out good doesn't mean that it got out of any hard parsing work. So there's your where clause predicates with the status equals open, even though it doesn't appear in our view. You have to go up above and see the explained plan or the SQL text that it actually submitted after the query transformation. So there's the outline. Outlines I think are kind of interesting. You put all these hints in, you're going to get that same explained plan. I find this a neat learning curve. There's your optimizer feature enable and your DB version. So instead of setting these at the init.aura setting, you can just set these for the problem SQL. There's the leading hint that I like to use. I've also used the use nested loop on occasion. So in the class, I talk about the hints that I've had success with. So here is the optimizer hints used for this particular one. It should match up with the other one. Go down through here. And then one of these lists is all the default settings. So this trace might be very useful. There's all these fixes again. Again, when I come up with this, I'm going to get rid of all of these fixes. So query signature blocks, some more useful information. Repeats the SQL statement. There's the legend again. And here's the parameters with the default values. So again, DBAs might find some of this of some use. I've actually solved performance issues by comparing current init.aura settings to their default values, and just run any SQL statement with the 1053 trace, and you'll get this information. It's pretty easy I just print it and line them up. I found it pretty easy to find some issues sometimes. So you can use it for different ways. There's those silly fixes again. Again, when I come up with my display for this, I'm going to clean this up. And I'm going to put different things in different panels. I'm going to pull that query transformation stuff out, put it in a tab, put different things in different tabs. So we get down here, there's the query transformation again. Final query after transformation. I want to make sure to show this. So there's our final query after transformation. And let's look out here to the right, and we will see the and a status equals open. So that is final query after transformations. That's the query that got submitted on your behalf. Okay? And you don't really see it anywhere else. It gives us all this information again. I'm not quite sure why they duplicate and triplicate up some of the information. Just trying to see if that was the one that it ended up using. Just looking at this one quickly, I don't see anything new in here. You can see that it doesn't have our a status equals open business, even though it shows up in the where clause predicates. And what does this dump say? So this was, again, the settings as they appeared. I'm probably not going to, some of this stuff I'll clean up for you. What I want to show you at the very end is dumping hints. If you had hints in your SQL statement, it'll have this section called dumping hints. I'm going to give this its own tab as well. Remember, we had a use nested loop and a leading hint. Okay, there's the hints. There were no errors in this hint. It did resolve the hint. It did find the hint. There were no errors in the hint. And it did use the hint. Okay, reasons it might not use the hint is during query transformation, it was out of context, so it didn't use it. Okay, so it can find the hint and then use the hint. Errors would be syntax errors. There's a syntax error in the hint, so it didn't use it. But this is what I'm looking for with hints, and this might be useful if you're working with a lot of hints. Why didn't it take my hint? You can run this trace, this 1053 trace, and look here at the end, and it will give you this information for your hint on, was there a syntax error in it? Did it find it, and did it use it? And if it didn't use it, it probably had a conflict with another hint that was in the list, or it was out of context for any query transformation, or you asked it to do something it wasn't capable of doing. You asked for an index that wasn't available. You asked for a parallel operation on a non-parallel type system, stuff of that nature, or other reasons it wouldn't use a hint. So there's our ABC example, and I used that trace. It did use both those hints. And in this particular one, there's again the errors in the hint. Hint was considered during processing and hint was used. So in this case, it did use all the hints. So I find this trace useful, especially from an instruction point of view, because I talk about the permutations. I talk about the different things that the cost-based optimizer goes through when processing, doing a hard parse on your SQL statement, and this trace shows it. Why I'm going to put up a display for this is because I find the output kind of a kludge. When I put the display up, it will work with the database directory. You'll need permission to alter a session, and you'll need permission to that database directory, and then I will pull this back for you. You don't need to email the DBA or any of those things. I will pull this information back, and I'm going to display in several tabs the useful information, including the init.aura settings. So I'm going to break up the information a little bit across some tabs. I'm probably going to have a tab just to show you the raw trace file as well. So So watch for the tool. I hope you found this information useful. If you'd like to learn more about the cost-based optimizer internals, Jonathan Lewis wrote a really good book on the cost-based optimizer fundamentals. I find this a good reference book and a good book if you're going to be working with the 1053 trace. So hopefully you found this information useful. I'm going to have the slides and a link to this presentation up on my website shortly. Hope to see you next week. I'm doing an OBIEE topic. If your shop happens to use this, please encourage people to come in and sit in on the presentation. I'm going to talk about key performance indicators, KPIs, and how to get those in. Thank you for participating. Remember me for your training needs and do keep in touch. And again, if anyone has written some PL SQL that spawns a task on the server, if you don't mind sharing your code with me, that would help me when processing the 1046 trays. Thank you. Have a great day.